Diksha, good evening. Thank you for joining the class. Yes, hopefully many of you are going to join the live class. Please let me know in the comments whether you are able to hear me correctly and you are able to see the screen. Okay, that is very important. So, good evening Varsha, good evening Komal, and hopefully everyone is fine. Good evening Jyoti. And yes, most of the times I am taking class at this moment because the reason is simple. To live stream the class we need a very high quality internet. Okay, so yes, I have installed that, and please you have to cooperate with the timing. In the daytimes we cannot have the class, there are many other issues with me, and hopefully later if you have missed the class you can watch it later also. So good evening Diksha, Priyanka Rani. Okay, so everyone who has joined the class, please like the videos, and yes, if you are going to have any question you can write in the comment. I am now able to see your comments live. Earlier I was not able to see, I have to use my mobile phone, but now I can see your comments at the same moment, and hopefully every one of you are fine and doing well. Yes, please, this is a COVID-19 time and many of the students, they are thinking that it is not a good time to prepare for your exam, but I will say that the person who are going to utilize their time in the best way, okay, they will be successful. Yes, through technology we can interact with each other, and hopefully you must utilize the proper use of the technology. And now we are going to start the class. Okay, so thank you everyone who has joined the class, and in today's class we are going to discuss a very important topic, that is ketone bodies. Okay, so I just want to tell you that we have to learn a very important topic, that is the synthesis of cholesterol. But before synthesis of cholesterol we have to also learn the topic, that is ketone body synthesis, because later you will see that both of the steps, they are going to have some common pathways. So it will be nice that we are going to have both of the topics together. So good evening Priyanka, Deepika Soni, Dipti Rathi, Priyanka Jakar, okay, Diksha, Komal, Jyoti, and now we are going to start the class. Okay, hopefully you are getting my voice clear and you are able to see the screen. So let us start the class. Hello students, welcome to my channel Deep Learning Biology. In today's live class we are going to learn about ketone bodies. Okay, so I just want to tell you some of the important points. Yes, you must have learned in your previous classes that carbohydrates, okay, for example the sugar, glucose, okay, they are going to be metabolized in series of steps, and finally you are going to have the production of acetyl CoA. Yes, many of the amino acid, okay, they are also being degraded and they are going to be converted to acetyl CoA. yes, you are going to have the same many of the fats, okay, fatty acid, they are also going to be converted to the acetyl CoA. Now you see all these carbohydrates, amino acid, fatty acid, they are finally degraded to acetyl CoA. Yes, from acetyl CoA, that it can give rise to fatty acid, it can give rise to amino acid, it can give rise to sugars, okay, its precursor. So acetyl CoA, it is actually playing a very central role. Now if you see in different cells, what is going to happen, there is going to be production of acetyl CoA, and this acetyl CoA, it is going to enter into the citric acid cycle, and through citric acid cycle, you know that there is generation of energy, and we have already discussed the steps of citric acid cycle. So these steps, they are going to occur in the normal cell, but in the liver cell, okay, in the liver, the acetyl CoA which is going to be produced, it is going to have two fate. One fate is that it can enter into the citric acid cycle. Yes, another fate, it can lead to the production of ketone bodies. So in today's class, we are going to learn how the ketone bodies, they are being produced within the liver. And yes, if you see the term like bodies, it will give you a sense that it is something insoluble. But I just want to tell you that ketone bodies, they are actually polar in nature. They are quite soluble, okay. So most of the times these ketone bodies, they are going to be secreted in the blood. Yes, it is also excreted through the urine. So ketone bodies, always remember, they are not insoluble aggregates, they are quite soluble, but I don't know the reason, but still they are going to use the term ketone bodies. Now I have told you that ketone bodies, they are actually produce ketone bodies, they are actually produced within the liver. And here I just want to tell you one important fact, that three chemical, one is acetoacetate, okay, and second is D-beta hydroxybutyrate, and the third is the acetone. All these three chemicals together, they are known as the ketone bodies. And the synthesis of ketone bodies, where it is occurring within the liver. And who is the precursor? It is the acetyl CoA. This synthesis of ketone bodies within the liver is also known as a process that is known as ketogenesis. So what is ketogenesis? It is the synthesis of ketone bodies, and one of the main organ which is involved in synthesis of ketone body, it is the liver. Now try to see here, all these three chemical, acetoacetate, D-beta hydroxybutyrate, as well as the acetone, all these three together, they are known as the ketone bodies. Now here I just want to tell you one important fact. These ketone bodies which are being produced, okay, the two, acetoacetate and D-beta hydroxybutyrate, they can be utilized by other cell as an energy source, but acetone, it cannot be utilized by our body. So another important thing you must remember, acetone is going to have the least concentration, means it is the least one which is being produced when the liver is going to synthesize the ketone bodies. And as I have told you that acetone cannot be utilized by the human body, it is being exhaled. It is being exhaled through breath. Okay, so sometimes you will see that some of the person, they are going to have a very sweet smell in their breath. Okay, and actually this is due to the exhalation of acetone. Yes, we will learn today that ketone bodies production, it actually enhance in two conditions. One is starvation, when a person has not taken food from many days. Yes, another condition is diabetes. In diabetes also there is more production of ketone bodies. So we will discuss in detail why there is more production of ketone bodies in both of the conditions. So hopefully these points are clear to you. Now if you see within the liver, okay, there is production of ketone bodies. Okay, now these ketone bodies which are being produced within the liver, okay, they are to be exported to other extra hepatic tissue like skeletal muscles. Okay, it will be export out from the liver, and now these ketone bodies, they will be going to skeletal muscles, okay, then heart muscles, then your renal cortex. Okay, so all these tissue, they can use ketone bodies as energy source. Okay, this is the main important point. Yes, most of these tissue, they are going to primarily use glucose as the energy source, but in condition when there is more accumulation of ketone bodies, that can also, then these tissue, they can also use ketone bodies as the energy source. Here I just want to tell you another important point. Your brain, okay, its primary energy source, it is glucose. Okay, your brain cannot use fatty acid as the energy source. The reason is simple. The fatty acid, they cannot cross the blood brain barrier, so they cannot reach to the brain. Okay, so brain cannot use fatty acid as the energy source, but brain under the condition of starvation. So when there is starvation condition, means when you have not taken food for many days, your brain can adapt and it can use ketone bodies as the energy source. Okay, so you see that after the glucose and other primary source, your secondary source of energy, it is the ketone bodies. Hopefully everything is clear to you. Now we are going to discuss that, yes, I have told you that ketone bodies, they are being produced within the liver, and here I just want to tell you, within the liver, it is the mitochondria which is responsible for the synthesis of ketone bodies. So liver mitochondria is responsible for synthesis of ketone bodies, and within the liver mitochondria you are going to have various enzymes which are going to be responsible for the synthesis of ketone bodies. For example, some of the enzymes which are going to play an important role in synthesis of ketone bodies are: one is thiolase, second is HMG coenzyme A synthase. Third is HMG coenzyme A lyase. Yes, there are other enzymes like acetoacetate, acetoacetate decarboxylase. And the last enzyme we are going to discuss, it is D-beta hydroxybutyrate. Okay, butyrate, then dehydrogenase. So these are some of the enzymes, okay, which are going to play an important role in the synthesis of ketone bodies. Now we are going to discuss the biochemistry of synthesis of ketone bodies. Now I just want to tell you that precursor for the synthesis of ketone body is acetyl-CoA, your acetyl-CoA. So in the first step, you see what is going to happen. CS3 C double bond O SCOA. So this is your acetyl-CoA. 2 molecules of acetyl-CoA. So let us draw these 2 molecules of acetyl-CoA. They are going to join together by the action of an enzyme, okay, which is known as thiolase. Okay, so this is the enzyme which is actually playing an important role at the last step of beta oxidation of fatty acid. Okay, so when we are going to discuss beta oxidation, we will see the role of thiolase enzyme. Yes, at this step you will see there is going to be release of coenzyme A. So one coenzyme A, it is going to be released and there will be synthesis. So these two, they are going to condense and there will be synthesis of acetyl coenzyme A. Okay, this will be synthesized. Now in the next step, what is going to happen? By the action of an enzyme known as HMG CoA synthase. Okay, what will happen? There will be condensation of third acetyl-CoA. So earlier what is going to happen? This acetyl-CoA and this acetyl-CoA, they both condense together and it lead to the synthesis of acetoacetyl-CoA. In the next step, what is going to happen? Another acetyl-CoA, okay, it will be condensed with the acetoacetyl-CoA by the action of enzyme HMG CoA synthase. What will be the net result? There will be synthesis of HMG CoA. Now here I just want to tell you this HMG CoA is actually beta hydroxy beta methyl gluteryl CoA. Okay, so you see there is synthesis of HMG CoA. Now you have to think here that this thiolase enzyme, okay, it is playing a role in last step of beta oxidation, but here it is also playing an important role in condensation of these two acetyl-CoA. So these two acetyl-CoA, they are going to condense first. There will be synthesis of acetoacetyl-CoA. In the next step, what is going to happen? Another acetyl-CoA, it will be condensed and there will be synthesis of HMG CoA. Now here I just missed one point, that there is also a release of coenzyme A. Okay, so whatever coenzyme A it is bound to here, it will be released. So in these two steps, they are occurring in the mitochondria matrix. Now I just want to tell you that mitochondrial enzyme, both mitochondrial enzyme. Which one? This thiolase and HMG-CoA synthase. They are responsible for synthesis of HMG-CoA. Now, I just want to tell you another important point, that within the cell, liver cell, within the cytosol, you are going to have cytosolic enzyme. Okay, which one? Both. This thiolase as well as HMG-CoA synthase. Now, those cytosolic enzyme, they are also going to play an important role, and there also there will be synthesis of HMG coenzyme A. So within the mitochondria there is synthesis of HMG coenzyme A. Within the cytosol, with the same step, okay, there is synthesis of HMG coenzyme A within the liver. So within the liver, this HMG coenzyme A, it will lead to the production of ketone bodies. Okay, while this HMG coenzyme A, it will be converted and it will be used as a precursor for synthesis of cholesterol. So always remember that within the liver, cholesterol synthesis is being done. Okay, it is taking place, but who is responsible? It is the cytosolic enzymes. While the mitochondrial enzymes of the liver, they are also synthesizing HMG-CoA, and that HMG-CoA will be converted to the ketone bodies. So in today's class, we are going to discuss how this HMG coenzyme A will lead to the production of ketone bodies. Now try to see here. Your HMG coenzyme A, which has now been produced, okay, by the action of an enzyme known as HMG coenzyme A lyase. Okay, yes, here also you will see there will be release of acetyl CoA. So acetyl CoA will be released, and what is going to happen? There will be synthesis of acetoacetate. Okay, acetoacetate will be synthesized. And here I just want to tell you the reaction which is being catalyzed by HMG coenzyme lyase, it is actually having a mechanism which is actually reverse of citrate synthase reaction. Another important thing, this enzyme HMG coenzyme lyase, it is only present within the liver mitochondria. Okay, it is not present other places. So what is happening? So next step, so the synthesis of ketone bodies, they are going to occur within the liver and within the liver mitochondria. So acetoacetate will be synthesized. Next, what is going to happen? This acetoacetate, it will be reduced. So there will be a reduction. Yes, there is going to be need of reducing agent. So in that case, NADH plus hydrogen ions, they will be converted to NAD plus, and another mitochondrial enzyme D-beta hydroxybutyrate dehydrogenase. Okay, by the action of this enzyme, your acetoacetate will be converted to D-beta hydroxybutyrate. Okay, so this will be synthesized. Now here another important point you must see. Here we are mentioning D. Hopefully you know there can be D and L conformation. Okay, so D-beta hydroxybutyrate dehydrogenase, it is going to act only on the D isomer. So it is going to synthesize D form. Yes, there is L-beta hydroxybutyrate dehydrogenase, another L-beta hydroxybutyrate dehydrogenase. That enzyme, the L, it is going to play an important role in beta oxidation. So that is a separate enzyme, but this one, it is going to lead to the production of ketone bodies. Now try to see. I have told you that there are going to be three chemical. One is acetoacetate, okay, and another is D-beta hydroxybutyrate, and the third, it is acetone. All these three together, they are going to form ketone bodies. Now we will see what is going to happen in the next phase. This acetoacetate, we have seen it can be converted to D-beta hydroxybutyrate, okay, and this acetoacetate, it can undergo spontaneous decarboxylation, means there is removal of carbon dioxide, or it can happen by the action of an enzyme, that is acetoacetate decarboxylase. So this acetoacetate, either by on its own or by the action of an enzyme, that is acetoacetate decarboxylase, it will be converted to acetone. Okay, so all these three, acetoacetate, acetone, and D-beta hydroxybutyrate, all these three together, they are known as ketone bodies. And where the ketone bodies production is taking place, it is taking place within the liver. Now I have told you, this acetone, it cannot be utilized by the cell, it cannot be utilized by the human body, it will be released out, it is toxic. So what is going to happen, it is going to be released out. Another important thing, it is volatile in nature, so most of the times it will be released out with the breath. Okay, so if you are going to see some of the person in their, if their smell is having some alcoholic type, okay, they might not have drunk, okay, but still they are going to have some releasing their acetone, and this can happen when their body is synthesizing excess amount of ketone bodies. Now I just want to tell you, in case of untreated diabetes, there is going to be a large production of acetoacetate. Yes, if there is going to be large production of acetoacetate, there will be more accumulation of acetone. Yes, when a person is going to release acetone in their breath, what will happen, it can give you an indication that the person is going to suffer from the disease diabetes. Yes, we will discuss how in the diabetic condition there can be an accumulation of more ketone bodies. Now I just want to tell you that we have discussed that ketone bodies, they are being produced within the liver. So liver is the site where the ketone bodies production is taking place. Now if you remember, I have told you that ketone bodies, they are polar in nature, means they can be easily transported through blood to other extrahepatic tissue, to other tissue it can be transported. Now we will see what is going to happen when these ketone bodies, they are going to enter other tissue. Now one of the thing, let us start how other cell they are going to utilize the ketone bodies. I have told you, other cell they cannot use acetone, they can use either D-beta hydroxybutyrate or they can use acetoacetate. That's both they are going to enter into the cell. Now let us start D-beta hydroxybutyrate. Now this D-beta hydroxybutyrate, okay, it will be metabolized Okay, please correct the spelling. So this D-beta hydroxybutyrate, it will be oxidized to acetoacetate. Okay, and this reaction is being catalyzed by the enzyme that is D-beta hydroxybutyrate, okay, dehydrogenase. Now here you see there will be oxidation. Now NAD plus, it will be converted to NADH plus hydrogen ions. Okay, so what will happen? There will be synthesis of acetoacetate. Yes, acetoacetate also enter in the cell. Okay, that will remain acetoacetate. Now we will see what is going to happen in the next step. In the next step, what is going to happen? By the action of an enzyme known as beta ketoacyl coenzyme A transferase. Okay, so it is a coenzyme A transferase, means it is transferring the coenzyme group, and this enzyme is also known as thiophrase. So who is the donor here? It is succinyl-CoA. Succinyl-CoA will donate the coenzyme A. Yes, succinate, it will be formed, and now acetoacetate will be having the coenzyme A. So what will be the synthesis? It will be the synthesis of acetoacetyl CoA will be synthesized. Now in the next step, by the action of enzyme thiolase, okay, this is the enzyme, this acetoacetyl CoA, by using another CoA, so what is going to happen? It will be broken down to 2-acetyl CoA. Now this acetyl CoA, now you see these steps we are talking what is going to happen when other cell, they are going to pick these ketone bodies. So D-beta hydroxybutyrate, it will be converted to acetoacetate, then acetate will be converted to acetoacetyl CoA, and finally acetoacetyl CoA, by the action of enzyme thiolase, it will be converted to 2-acetyl CoA. And hopefully you know very well that acetyl CoA now can enter in the citric acid cycle, and it can give you the energy. Now here there is a very important fact. This enzyme beta ketoacyl CoA transferase, known as thiophrase, okay, this enzyme, okay, which is responsible for synthesis of acetoacetyl CoA, this enzyme, it is absent in liver. Try to see which enzyme? Beta ketoacyl CoA transferase. This enzyme, it is absent in liver. Try to think here. Liver, within the liver there is production of ketone bodies, but liver cannot use ketone bodies as the energy source. Reason is simple. The liver cell, they lack the enzyme thiophrase. So thiophrase enzyme, it is absent within the liver, so they cannot use, the liver cannot use ketone bodies as the energy source for itself. But these ketone bodies, they can be used as an energy source by the skeletal muscles, by the brain cell, by the heart cell. But liver is actually the producer of ketone bodies, and it cannot use ketone bodies as the fuel. The reason is simple. Liver lack the enzyme thiophrase, okay, which is responsible for the catabolism of ketone bodies. So other tissue, they are having this thiophorase enzyme, so they can use ketone bodies as the energy source. Now I just want to tell you a very important point. Untreated diabetes means when a person is not having any treatment for the diabetes, or in the condition starvation, when a person has not taken food for many days. Both of these conditions can lead to an increased production of ketone bodies. Okay, and where the production is happening? It is happening within the liver. Now we will discuss how starvation as well as this diabetes condition, it is going to lead to increased ketone bodies production. Okay, now try to see here. In the condition starvation, okay, when a person has not taken food from many days, what will be going to happen? The liver glycogen, okay, you know very well, liver is going to store glucose in the form of glycogen. It will start reducing and it will be exhausted within 24 hours. So liver glycogen will be reduced. Yes, after starvation, the blood glucose level, so glucose level within the blood, it is also going to decrease. Now when there is low blood glucose level within your body, there is a mechanism which actually take place also within the liver, that is known as gluconeogenesis. Gluconeogenesis. Okay, and I just want to tell you, gluconeogenesis is actually a process in which glucose is being synthesized from non-carbohydrate source. Okay, and this happens within liver and kidney. Okay, because your body is in need of glucose. So what will happen? Gluconeogenesis, it will be promoted. Now I just want to tell you, to carry out gluconeogenesis, your body actually need citric acid cycle intermediates. So your citric acid cycle intermediates, okay, they are going to be used, and what they are being done? They are being converted to glucose. So when your citric acid cycle intermediates, they are being used, what will be the end result? There will be less concentration of oxaloacetate within your body. Now when your body is, your cell, it is going to have less concentration of oxaloacetate, what will be the result? You know, at the first step of citric acid cycle, what is there? Is synthesis of citrate. That is not going to occur. Okay, so your citrate synthesis process, it will not occur. So citrate synthesis will not occur. So this is going to happen. And what will be the end result? If you remember, acetyl CoA, it is being converted to citrate. Okay, so there will be accumulation of acetyl CoA. So this will start building up. Same way, when a person is starving, he has not taken any food. Yes, you know very well, our body has the mechanism that it can store energy in the form of fatty acid. So earlier your cell is going to prefer glucose and other carbohydrate source, but when your body is in demand of energy and glucose is not available, then it will start metabolizing fatty acid. So your fatty acid, they actually undergo beta oxidation. So your fatty acid, okay, they are undergoing beta oxidation. That beta oxidation of fatty acid will also increase the concentration of acetyl CoA. Now what will happen? You know very well, we have now discussed that in total there is going to be increase in the concentration of acetyl-CoA when the person is under starvation. So increase in the concentration of acetyl-CoA within the liver, it will lead to the synthesis of more ketone bodies. So ketone bodies, they will be synthesized, because we have discussed now how acetyl-CoA, they condense and they lead to the formation of ketone bodies. Hopefully it is clear to you. Next, we are going to see the condition when you are going to have untreated diabetes. So when you are going to have untreated diabetes, in that condition, you see your blood glucose level is high. Yes, in the previous condition we see the blood glucose level was less, but here in case of diabetes, you see, yes, blood glucose level is high, but your cell, your tissue, they cannot uptake glucose. You know that insulin, okay, level is insulin hormone is absent, or the action of insulin hormone, they are not taking place. What is going to happen? There will be scarcity of glucose within the cell. So your cell is going to have low glucose, low energy state. Okay, so they are not having enough glucose. Now this low energy state, actually it is going to inhibit an enzyme, okay, that is acetyl-CoA carboxylase. So this enzyme, its activity, it is going to be inhibited, and what will be the end result? There will be decrease in the level of malonyl CoA. So your malonyl CoA concentration, it will decrease, and your malonyl CoA, it is actually the precursor for fatty acid synthesis. So you see, when the malonyl CoA concentration has decreased, what will be the end result? Your fatty acid synthesis, it is being blocked. Okay, now I have told you that in case of diabetes, your cell is in need of energy. Glucose is there, but it cannot use glucose as energy source, so it will start looking for alternative energy source. What are those alternative energy source? Fatty acid. Okay, your fatty acid, it will be metabolized through a pathway, that is beta oxidation. Now this beta oxidation, it will continue. Now beta oxidation will continue, and it will lead to accumulation of acetyl-CoA. So you see, this acetyl-CoA, it is not going to be used for fatty acid synthesis. Okay, this has been blocked. Now there is more accumulation of acetyl-CoA, and I have told you this acetyl-CoA now can give rise to ketone bodies. So hopefully it is now clear to you that in both the condition, one is during starvation and during the condition when a person is suffering from untreated diabetes, in both of the condition there is accumulation of ketone bodies. Now we are going to have some simple point. When within the blood there is an increase in the concentration of acetoacetate, and there is increase in the concentration of D-beta hydroxybutyrate. Okay, so what is going to happen? These ketone bodies, now they have accumulated within the blood. It is going to lower down the blood pH. Your blood pH will fall, and this condition is known as acidosis. So always remember, when there is accumulation of ketone bodies, okay, so when there is increase in concentration of ketone bodies, okay, it will lead to acidosis of the blood, and that's why this condition is also known as ketoacidosis. Now extreme ketoacidosis, it is going to be fatal. A person can go in coma or even death can occur. I just want to tell you that the concentration of ketone bodies in normal adult, it is going to be 3 milligram per 100 ml of blood. And most of the times in a normal, so this is, we are talking about the normal condition, okay, your ketone bodies, their concentration, it is going to be 3 milligram per 100 ml of the blood. Yes, I have told you that ketone bodies, they are soluble in water, and yes, most of the time they are going to be secreted through urine, and you will see approximately 125 milligram of ketone bodies, they are going to be secreted from your body in 24 hours. But in condition like when you are going to have untreated diabetes, okay, so you see that in those person the concentration of ketone bodies, it can go 90 milligram per 100 ml, and yes, there is going to be secretion of ketone bodies through urine, and it can also go higher, that is 500 milligram. So in today's class we have learned about the production of ketone bodies. Now here I just want to tell you something much important. You see, the breakdown of fat, okay, it can lead to the increased concentration of acetyl-CoA. Yes, breakdown of carbohydrates as well as some amino acid, it can lead to the increase in the concentration of acetyl-CoA. Yes, I told you acetyl-CoA can be converted for fat synthesis. Okay, yes, acetyl-CoA, here the most important point I just want to tell you that acetyl-CoA cannot be used for the synthesis of carbohydrates. So always remember, in case of animal cell, there is no net conversion of acetyl-CoA to carbohydrates. Yes, acetyl-CoA can be used for synthesis of carbohydrates by the use of gluconeogenesis, but there is no net conversion of fat to carbohydrates. So this is very important point. In animals, there is no net conversion of acetyl-CoA to carbohydrates. Yes, in case of plants and microorganisms, okay, what is going to happen, the acetyl-CoA, it can be converted to carbohydrates. So there can be net synthesis of carbohydrates, okay, from the fats, and it is from the fat. The fat, they are going to give rise to acetyl-CoA, and that acetyl-CoA is converted to carbohydrate, and this happens through a cycle that is known as glycosylate cycle. Okay, so always remember that animals, this is very important, animals, yes, they can convert carbohydrates to fat. Okay, so if you are not taking any fatty diet, and if you are taking a very high calorie diet which is rich in carbohydrate, what will happen? Carbohydrates, they will be finally metabolized to acetyl-CoA, and acetyl-CoA can be converted to fat. Okay, this can happen in the animals. But the fat, yes, fat is also going to be oxidized by beta oxidation. It is going to give rise to acetyl-CoA, but that acetyl-CoA cannot be used for the production of carbohydrates. Okay, so always remember that in animals, the fats, they cannot be converted to carbohydrates, but carbohydrates, they can be converted to fat. So this is for today's class, and at the last I want to define what is actually ketone bodies. Okay, so hopefully you have learned. Now I want to define it. Okay, ketone bodies, they are actually the substance, which substance? Acetoacetate, acetoacetate, then beta hydroxybutyrate, and you have acetone. Okay, all these three substances which are produced actually from excess of acetyl CoA. They are being produced from acetyl CoA in the liver, and when they are being produced, when the fatty acid beta oxidation, it is going to exceed. So when within the liver the beta oxidation of fatty acid, it is occurring at a fast rate, what will happen? There will be accumulation of acetyl CoA, and then acetyl CoA, it is not being used as an energy source. Your citric acid cycle intermediates, they have vanished, so acetyl CoA, it is being accumulated. Then it is going to lead to accumulation of these three substances: acetoacetate, beta hydroxybutyrate, and the acetone. So always remember, ketone bodies, they are the substrate, acetoacetate, beta hydroxybutyrate, and acetone, which are produced from excess of acetyl CoA in the liver when rate of fatty acid beta oxidation in liver mitochondria exceed the rate at which acetyl CoA is used for energy generation. Thank you for watching this. Have a nice time. If you have any question, you can write in the comment.